Hey everybody. So this is our last lesson in this section before we have a test. So we'll have our test next class. So this is just going to be kind of the culmination of stuff that we've been learning. We've been working on solving a lot of things, and ultimately we're not really going to go too far from that. I want to consider something weird that can happen when you're solving. So we're actually going to jump right into an example. So 2 parentheses 3x plus 5 close parentheses equals 6x minus 9. So this is a special case, a special thing that can happen. Okay, so we're going to go through our normal process of solving, and I want us to see what happens. It's kind of like an experiment. So there's no fractions to kill off. There is stuff to simplify. I can distribute here. See, 2 times 3x is 6x. And let's finish our distribute. Plus 10 equals 6x minus 9. Now remember, our third step of solving, when we have all our steps written out, says to get the x's on the same sides. And you notice I have x's on both sides. So what we'll do is, let's see, how do I get rid of 6x here? I'm going to subtract 6x from both sides. But something different happens this time. Sure, it cancels out on this side, but it also cancels the x's out on both sides. I'm left with this statement, this equation of 10 equals negative 9. But this is not true, is it? This is not true in the least bit. 10 does not equal negative 9. So there is a special case where your x can disappear completely from the problem. And that's going to be one of two things. You're either going to be left with a true statement or a false statement. If it's a false statement, what that means is that there is no possible solution. So no solution. No matter what you plug in for x, you cannot get a true statement, a true equation. So whenever you're left with a false statement, the answer is simply no solution. Okay. Let's look at another example. One like this. Let's go with 2 parentheses x minus 3 close parentheses plus 3x equals 5x minus 6. So once again, we'll just go about solving it. There are no fractions to kill off. There is some simplifying that I'm going to have to do. So let's see, that'll be 2x minus 6 plus 3x equals 5x minus 6. And then I can finally combine these like terms. 2x plus 3x is 5x minus 6 equals 5x minus 6. And you can kind of see these special cases coming before you even make it to the end of the problem. But let's go ahead and finish it out, subtracting 5x from both sides to try to get the x's on the same side. And you will notice that both are gone, and you're left with negative 6 equals negative 6. And so in this case, you look at it, and this is a true statement. This is not the answer, because I don't have x equals something. I don't even know what x is. But it's a true statement. When we have this, what this means is that it could be any number, or at least in this case, all real numbers. So any number that you plug in to check, so say I say pick your favorite number and plug it in to check to see if it's a solution, to see if it's true, and it will be true. So all real numbers is the case. That's what we will write for our answer, all real numbers. And that is when you solve this thing, and it comes out where the x's disappear, but you have a true statement. So there's two possibilities when the x disappears. Either the statement left is true, or the statement left is false. If it's false, there's no solution. If it's true, any number will work. You can just tell me all real numbers. Okay? So that's a neat little piece of solving. Now, we want to take our solving to another level. Okay? So let me show you something. 3x minus 2y equals 8. Sometimes there's more than one variable type in our equation. Can we still solve it? And the answer is yeah. So for example, if I want to solve this for y, it's an ugly y, sorry. if I want to solve it for y, could I do that? Yeah, it's actually the same process. It's not any different. So, are there any fractions to kill off? No. Before we start, let me point out, though, if we're solving for y, that means that I am trying to isolate y. So I get to move everything away from y. We'll solve it the same way. We'll just pretend that 3x is a number. I mean, it is a number. We just don't know what x is. So let's go to town with this. Going through our solving steps, there are no fractions to kill off. There's no parentheses to distribute or like terms to combine, so there's no simplifying that has to happen. Y is already on a side, so I just need to get rid of things. Remember, we start further away. So this is just like a number. It is a positive number because you look up front, there's nothing there. So I would need to subtract 3x from both sides. So even if that was just 10, you would have done the same thing. You would have subtracted 10 from both sides. Because there's an x there doesn't mean anything different. So we subtract 3x from both sides. When we do that, the 3x's are gone, and you're left with negative 2y equals. Now 8 and 3x are not like terms. They're not like because 8 is a number with no x, and 3 has an x with it, so I cannot combine them. So simply, they just get written as 8 minus 3x, because I cannot add or subtract those numbers together. They just get written out, which is okay. Now, have I gotten y all by itself yet? No, there's still that negative 2 there, but we know how to deal with that. We know how to solve. We would say, divide by negative 2. So I'm going to want to divide every term on this other side by negative 2. Okay? Now, what happens when I do that, I get y equals, let's see, 8 divided by negative 2 is negative 4. Negative 3 over negative 2, that becomes a positive, but it's still just 3 over 2 with the x. So y equals negative 4 plus 3 over 2x. So is the y by itself? Yes, it is. So we have solved it. So yes, we don't get a nice pretty y equals 7 or something like that, but we get an expression, a whole equation that y is equal to this entire piece with the x in it. Okay, so we could do this. We could solve, they're called solving formulas because they have more letter types in them. For instance, I could solve for w. This is a famous formula I'm fixing to put down. It's the volume equals length times width times height. I could solve for w. What you look and say, is w by itself? No, what's with it? An L and an H. And I could get rid of the L and the H in the same step here. They're both being multiplied, so I just need to divide both sides by L and H. So the L's would cancel, the H's would cancel, and you're just left with a W. Well, what is W equal to? V divided by L over H. And these, there's nothing you can do with these letters. Did I get W by itself? Yeah. So we have achieved what we wanted. Yes, I know it's not a pretty number, but that's okay. It's not like W equals 7. It is just some expression. That is a-okay. We were just trying to get W by itself and simplify our answer as much as possible, but this does not simplify. So one or two more examples of those, and we'll call it done. All right, so how about this one? Solve for B. Okay, so let's say that perimeter equals A side plus the B side plus the C side. So could you solve that for B? Well, is the B alone? No. What's with it? Plus A and a positive C. So I can subtract these off from both sides. I'm going to do this carefully in two separate steps, but if you're really, really fast at this, you could kind of smush those into a same step. So I subtracted A from both sides. B is not all by itself yet. I just need to subtract C from both sides now. So P minus A minus C equals B. Notice none of these are the same letter, P, A, and C, so none of them can be combined together. So they just stay P minus A minus C. Now I have BL by itself, so I have solved for B. Yes, I know I don't know B is 6 or B is 12 or B is 100, but I do have B by itself, which is what I'm trying to do. I'm trying to solve for B. All right, let's look at another famous formula. Go with C equals 2 pi r. That's the formula for circumference. 2 times pi times r. And we want to solve for r. So, how are these things attached to r? By multiplication. So all I need to do is divide both sides by 2 pi. So c over 2 pi does not reduce in any way. C and pi are not alike. I don't want to even try to deal with that stress. All I'm left with over here is an r, so have I solved for r? Yeah, I have. So you see that solving with formulas is actually pretty simple. You may get one or two or so of those on your test. Okay, just take your time and isolate the variable they tell you to solve for. All right. Now, I have one little last bit of surprise for you. So that's it for all the material on test 2. All right. Now on test 2 in Blackboard, underneath this lesson, I will have posted for you, let's see if I can find it, a review. There it is. All right. I will post this with its answer key. This is just to prepare you for the test. You don't have to do it. You can do it. It's completely up to you. But these are everything that you could possibly see on the test. I will send an email with more information on our upcoming test in detail. Okay. You will have 1 day to complete it. Make sure that you complete it. I will send an email with the opening time and the close time. All right. So I hope you have, guys, a good day.